Good morning, friends. Today we will discuss about few elastic constant. We already know the linear strain. We know that the linear strain epsilon is equal to delta L upon L. Delta L is change in dimension or change in length in a direction of force. If we applied force in x direction, then the length will be changed in x direction, and this elongation will call delta L. And for that dimension, the original length, that we will call L, and this will be the ratio of that will be linear strain epsilon. But what if we increase the dimension of any object in a linear fashion, then there will be change in lateral direction. If we apply force in x direction, then there will be some change in y direction or z direction. So for that dimension, if we use that dimension in strain, this strain is known as lateral strain, and it is denoted by epsilon dash. So what is lateral strain? It is change in lateral dimension upon original dimension. And as I already said, it is denoted by epsilon dash. Epsilon dash is equal to delta D upon D. If we have bar and we applied force in its length, along its length, then the change in its length upon original length is known as linear strain, and change in diameter upon original diameter is known as lateral strain epsilon dash. So the ratio of lateral strain upon linear strain is known as Poisson's ratio. It is denoted by mu or 1 upon m. Uh, in our previous lecture, we understood how the dimension are change in one direction only. If we want to use the dimension, or if we analyze more than one dimension of, if we analyze in y direction, what is change in y direction or what is change in z direction, then we have to use Poisson's ratio. And next term is volumetric strain epsilon v. Epsilon v is change in volume upon volume, same as epsilon delta L upon L. Now volumetric strain is epsilon v is equal to delta v upon v. It is the summation of x direction strain, y direction strain, and z direction strain. Next term is bulk modulus. Now what is bulk modulus? Bulk modulus K is equal to direct stress upon volumetric strain. If we apply force in x direction, then we will consider direct stress is in x direction, and then volumetric strain, we already know what is volumetric strain. It is delta V upon V. Now the relation between bulk modulus and Poisson's ratio and Young modulus is K is equal to ME upon 3M minus 2. Now we will use another term. It is known as modulus of rigidity. We already know modulus of elasticity. The modulus of elasticity will be used only for linear stress or strain or axial stress or strain. But If we will use shear stress or shear force, then we have to use modulus of rigidity or a shear modulus. It is denoted by C or N or G. It is shear stress upon shear strain, tau upon phi. Phi is shear strain and tau is shear stress. Now, the relation between modulus of rigidity, Young modulus, and Poisson's ratio is G is equal to ME upon 2 into M plus 1. Another relation is E is equal to 9GK upon 3 plus G plus 3K. This all equation we will use in our numerical. Now we will start our numerical. A bar of 300 mm, 100 mm and 50 mm, this is the actual size, is as shown in figure, and we have to calculate the volume strain term and also calculate the change in volume of a bar, and E is given, E is equal to 200 gigapascal. So this is bar. Tensile stress is applied in x direction, and tensile stress is applied in y direction. It is 400 kilonewton, and compressive stress is applied in x direction. The thickness of this bar is 50 mm, and the height is 300 mm, width is 100 mm. So first we will calculate the stress in x direction and stress in y direction. We all know the sigma is equal to force upon area. According to that, force in x direction is 400 kilonewton. So we'll use 450 kilonewton is 450 into 10 raised to 3 upon area. The cross section area for x direction force is 300 mm cross 50. 50 is thickness of this bar. So we get the 30 Newton per mm square stress, but it is in compression. Same way for y direction, we get the 80 Newton per mm square. It is in tensile. It is tensile stress, and there is no force in z direction. So sigma z is equal to 0. Now we already know the equation of, if we use the Poisson's ratio, then epsilon x or x direction stress will be sigma x upon E minus sigma y upon me minus sigma z upon me. This is the equation for if we use three-dimensional analysis for our object. Then we can use this equation for strain in a x direction. So we will use sigma x in minus because it is compressive, and sigma y in plus, but it is in minus in equation, and sigma z is 0. So we'll eliminate this last term. Now we will put sigma x, it is 30 upon E, and we will put sigma y is 80 and 1 upon m. Poisson ratio is given, it is 0.25 upon E. So we get the sigma x is equal to minus 50 upon E. Same way we can calculate the sigma y and sigma z. For sigma y, we just use sigma y upon E minus sigma x upon me minus sigma z upon me. And for epsilon z, we can calculate this. Now we already calculated the strain term in all direction, and last one is change in volume. We know that total change in volume or change in volume delta V upon V is equal to epsilon x plus epsilon y plus epsilon z. Now we will make delta V subject, then we can get the change in volume. It is 182.92 mm cube. Okay, thank you.